Now, the gradient of a line, sometimes called the slope or the rate of a change of a line, is given by the rule rise over run. Remember, we use the letter m, lowercase m, to represent gradient, because we all know gradient starts with m. Yeah, mathematicians aren't very good at spelling. So we're going to use this rule rise over run. So if I've given 2 points, I need to draw on a right angled triangle again to work out the rise and run between these 2 points. Remember, when I draw a right angled triangle, make sure your sides are parallel to the axis. So using the point A, which is across 2 up 1, and the point B, which is across 3 up 3, we're going to work out the slope or the grade of this line. So I draw a horizontal line in and a vertical line to create a right angled triangle. I now need to know what the units are, how far across and how far up I've gone. So here I've gone from 2 to 3, so I've just gone across 1. And here I've gone from 1 up till 3. So looking at my y values of 1 up to the y value of 3, I've gone up by 2. Now this is across, this is my run, and up and down is my rise. So if I was to find the gradient of this line AB, the gradient would equal the rise, which is 2, over the run, which is 1. Now as we're going left to right, we can see that this line is going up, so it is a positive gradient. So it's going to be positive 2 over 1. 2 over 1 would be much prettier if we just left it as 2. The over 1 is not needed. All right, let's pick some other points. Let's say I've got, okay, we'll start here. And another one over here. So let's draw that in. So let's look at the coordinates. Now over here, let's call this the point C. I've gone across 1 and down 2. So putting x first is 1, and then the y value of minus 2. Let's call this one D. So this time I've gone back 1 on the x-axis and up 1 on y. So putting x first is the minus 1, 1. So that's the slope I'm trying to look for now. I'm going to put my rise and my run in by drawing a horizontal line and a parallel to the y-axis, a vertical line. And there's my right angled triangle. Now looking here, my distance here, I've gone across 1, 2 units. Here I've gone up 1, 2, 3 units. So my run is 2 and my rise is 3. So I'm trying to find the gradient of this one. Rise over run, so remember rise, change in y on top, so the y changed by 3 and the run changed by 2. But when we look at this line from left to right, we're clearly going down. So it is a negative slope. So I need to make this a negative gradient. So it's negative 3 on 2. That's already fully simplified, so I'd leave that. Let's try one more. Let's put a point, it's getting a bit messy on the diagram, but we'll figure it out. So let's put one all the way over here. Let's call this the point E. Now its coordinates are across 3, down 4. So it's the point 3 minus 4. Let's stick another point all the way over here. I don't know, all the way up here. So we're going to call that F. Now it's gone back 3 on the x-axis and up 4. So it's the point minus 3, 4. So it's going to go through everything else, this one here. A bit messy. All right, now if I come across just straight under this one and straight under here. Okay, I've got to work out how far I've gone across. So I've gone from 3 all the way to minus 3. Now I've jumped back 1, 2, 3, 4, 5, 6 units. Here I've gone from minus 4 to positive 4. So the change from minus 4 to positive 4, it's gone up by 8. So I've gone across by 6 units and up by 8 units. So doing rise over run. So the rise is my change in y, so it's gone up by 8. And my run is my change in x, which is 6. Now, 8 on 6, is it positive or negative? Need to check that. Clearly, as I travel from left to right across this line, I'm going down. So it is going to be a negative gradient. So it's negative 8 on 6 so far. 8 on 6, though, does simplify. They're both divisible by 2, so I would make that negative 4 over 3 as my gradient. So you must always simplify if that's possible.